Okay, so here we continue on with our Space Invaders game. Right, we've got our control of our spaceship. It stops when it gets to the edges. We can fire the weapon, and then what I don't have up here because it's not quite done yet, is we can check for the collisions and cause, like the aliens to disappear after we hit them. Now the issue is we need to basically have a way to determine whether that we hit an alien, and then we need a way to check to see if we did. And so we started this on the last part where we're getting the alien status and we're setting an index. Now the issue is a Boolean is 8 bits, and so if we have which is a byte, and so if we have this many aliens, so 2 times 8, that's 16 bytes. If we have more, it's even more, and really we are pretty tight on memory because we're already using 725 bytes, and this is before we're then going into when we run the code, it's allocating memory for the display, which is we did the calculation before, it was I think like 1,000 bytes or something, so we're very tight on memory, and so we want to try to avoid that. And so what we're going to do is we created an array that's going to hold the status of the aliens, but the array is only going to be a couple bytes long, and basically there'll be a byte for every 8 aliens, and we have to kind of round up there. And so if we have 16 aliens, that's 2 bytes, but if we had 17, we'd have 3 bytes based on this calculation here, and that's coming up here at the top, where we are finding the total number of aliens by multiplying the rows and the columns, and then we're getting our array by taking the number of aliens, adding 7, and then dividing by 8. And so what that's doing is, if we have 16, that's giving us 2 bytes. If we have 17, that's giving us 3 bytes. If we have 20, that's giving us 3 bytes. If we have 24, it's giving us 3 bytes. If we have 25, it's going up to 5 bytes. Sorry, this is 3 bytes. Sorry, and it's going up to 4 bytes. Okay? And that's what's going on there. And so we had written this function, and I'm just going to review it because I did it kind of quick. And so we're doing a calculation here. Since we have an array that's got 3 bytes in it, or 2 bytes, you could think of these as our 2 bytes. So we have 8 bits and then 8 bits. And so let's say if we pass in, we want to find the status of alien number 10. And so if we index these, they actually start from 0. And so we're going to say this is the 0 index 10, and that's something we're going to have to handle in our calculation. But so 0 through 7 are the first byte, 0, 1, 2, 3, 4, 5, 6, 7. 8 through 15 are the second byte. And so in order to get number 10, we have to grab the second byte. And the way we do that, this is byte index 0, this is byte index 1. So here we find our position by dividing our index by 8. And so if it was a number less than 8, so like 7, we're going to get 0, and that will give us this first byte. If it's a number greater than 8, it's going to give our second byte. If it was a number greater than 16, it's going to give us the third byte, and so on. And so that tells us which byte our information about the specific alien is in. And then from there, we have to figure out how much to shift the position by, okay? And so then we do this modulus operation. It's giving us the remainder. And so when we do, so 10 divided by 8 is 1, and that gives us a byte position of 1. 10 modulus 8 is going to do that operation and give us the remainder. So 10 divided by 8 is 1 remainder 2, so our modulus operation is 2. And so that tells us we need to shift over 2. Now it's actually a little bit more complicated than that because we have to subtract away 7. Actually, I'm going to put that right here. So it's going to be actually 7 minus that index. And so the reason why this is an issue is because when we perform these calculations, we start reading with the least significant byte instead of the most significant byte. And so in an effort to avoid making this too confusing, I'm indexing from here going that way, and really it would go like this and then like this if we did it in the most natural way. And so our math is going to be a little more complicated here. We have to kind of switch the order in the byte, but really it would kind of be 0. Then this would be 0, 1, 2, 3, 4, 5, 6. Actually, 0, 1, 2, 3, 4, 5, 6, 7, and this one would be number 8, 9, 10, 11, 12, and so on. And so since we want this one to be number 8, we're doing that subtraction with the 7. Okay, so what happens here is we get our byte position and we access that first byte, which is right here. And what that's doing is it's getting not byte 0, but byte 1. And so we got byte 1. And then we're taking our bit shift amount. And so 10 modulus 8. And then we're going to subtract the 7. So 7 minus, or subtract from 7. So 7 minus 10 modulus 8 is going to be 7 minus 2, which is going to be 5. And so our bit shift amount is 5. And so we're going to take this value here, and we want to get the status of alien index 10. And so I had set it up here, I got it wrong here. So alien index 10 is right here. So 0 through 7, 8, 9, 10. So to get this, we have to shift it to the left, or sorry, to the right 5 times. Now this operation here, what it's doing is it's taking this number, and it's basically taking all the bits and it's shifting them every time one to the right and replacing the one that you shifted out with a 0. And so in this case, we shift it once and we end up with this, right? So that's 1 shift. This is 2 shifts, so we've shifted it twice. 3 times, 4 times, and here's the 5th time we shifted it. And so we started with the 10 in this position of byte index 1, our second byte, and we've grabbed that byte and we are shifting it until byte index 10 is at this position here, and then we perform the AND operation with 1. And what that's doing here, so we've done this, we've done the shift. The last step here is we are performing this AND operation with 1, and what the AND does is it's going to take what's left from our shift operation, and it's going to take the number 1, and it's going to compare all the places where there's data. And so if this was set as a 1, 1 and 1 is going to return 1. But since this is a 0, 0 and 1 is going to return 0. And so this will tell us that that current alien is not visible, and so it'll return false there. If this value was set as 1, then it's going to return 1, which tells us that alien is visible. And this is how we're going to keep track of the status. And as we mentioned, we have to do the reverse of this, where we actually set the alien status. And so this is similar. We're going to get the shift amount, and we're going to get the byte position, and we're going to actually set those values. And so what we're going to do is we're going to set that position of our array. But what happens this time is we have to make a mask. And so we're going to say uint 8t bit mask equals, and let's see, we want to set it to, so actually we want to turn it off, right? Well, we want to be able to tell it to turn on or off. I think I want to give us the most possible flexibility here, and so we're going to also tell it pass a bool visible. And so basically when it's set to true, true turns into 1, and false turns into 0. Okay? And so what we're going to do is we're going to take that value of visible, and we're going to shift it the bit shift amount. Okay? And then once we've done that, we're going to invert it using the not symbol. Okay? Oh, and it should be the opposite of this, right? So if it's, oh no, yeah, if we're getting rid of it, we're setting it to 0. Oh yeah, because we want this to be 1. Okay, so we're going to do the inverse of that. All right, and so now we're shifting it by the bit shift amount, and once that's done, we're going to perform an AND operation with the oh yeah, so that's our bit mask actually, sorry. Then we're going to perform the AND operation down here. And then we're going to say AND equals bit mask. Okay, and so now I'm going to take what we just did here. Oh, doesn't like that. Oh, got the semicolon there. Okay, and I'm going to explain what's going on there. Okay, while I was figuring this out, I realized it's not going to work the way we want it to. So we're going to get rid of this part, and we're going to get rid of this part. We're just going to put a 1. Because what was going to happen is when it was 0, it was just going to reset everything, which we do not want to do. Okay. But so let me explain what's happening here now. Okay, so what this is doing is this. So I went ahead and wrote this out. So let's say we want to set alien. We'll change the name of this function here. Let's say set alien, maybe like inactive. Okay. And so what we're going to do is we're going to take the index just like before, and we're going to perform the division operation here to get that we're in byte 1 rather than 0. We're going to do this calculation to get the shift amount. So 7 minus 10 over 8 is going to be bit 5, or a shift of 5 rather. And then we're going to grab, so and here's our state of our alien fleet. So looks like we got 1 missing in the back row and then 2 missing in the front row. And so we're going to grab byte 1. Okay, so this is byte 1. And then we got that right here with the byte position. And then for the bit mask, we're going to shift the number 1 to the left by 5. And so we started with 1, we're shifted 1, 2, 3, 4, 5. And so now the 1 is in this position. Okay? And now we've grabbed, and so once we've shifted it, the next step is we perform this not operation, or in which we invert it. And so what's happening now is this is getting inverted, and so now it's 1, 1, 0, 1, 1, 1, 1. One more there, one there. And so it inverted it, and this is our mask. And what we do is this allows us to disable just that bit without changing any of the other aliens. And so we're going to perform the AND operation with our bit mask now. And so we're going to go through one by one. And if they're the same, if they're both 1s, we're going to put a 1. If one of them is a 0, we're going to put a 0. And so what happened here was we started with this, and then we turned this 1 right here into a 0, and now we've ended up with this. Okay, and that way we've disabled that alien so it's no longer visible. Okay, and so coming back to now, we've called this set alien inactive. So coming now to here, when we do the collision, if we hit that alien, we're going to say set alien inactive, and we're going to have to get the alien's index. And so we're going to have another one called, let's say, we'll do it down here, void get alien index, and we're going to say uint8 t, and we'll say row comma uint8 t column, and so the way we're going to do this is typo there. So we're going to say row times num alien columns plus column. Okay. And we're going to return uint. So what this is going to do is, if it's in the first row, it's going to be 0 times 4, or let's say it's index row 0, and then index 4 in that row. And so to get that one, we're going to multiply the current row, which is going to be 0. So 0 times the number of alien columns, which is 8, plus 4, and so that's going to give us alien 4. If we're in the second row, that's going to give us alien 12, and so on. Okay, so that's what we're going to do to get our alien index. And then we're going to say get alien index, and we're going to send our row, which is going to be y, and our column, which is x. Okay, and then we're going to do the same thing down here. When we draw, we're going to say if get alien status, then we'll draw it. So if it's visible, we'll draw it. Okay, and so this now, if we get a collision, hopefully the bullet will disappear and the alien will disappear. So let's go ahead and test it and see if it works. Okay, so I haven't tested this yet, so we'll see if it works. A reminder that we also have this function where we check to see if there's a bullet collision, where we index through here the different bullets, and we call this function where we pass in our current bullet, and we check the if it collided with that alien. And if it did, we're going to set the visibility of that bullet to false as well. So we'll see if this blows up in our face right now. It should work. Oh, let's see. We only have one row of aliens now. That's interesting, right? And it looks like our bullet is disappearing, which is what we expect, but not the aliens. Okay? So let's think for a minute. Why might our other aliens not be visible anymore? Okay, so it looks like the issue is that when something's causing us not to get the second row of aliens. And so it could be just when we initialize it, I need to set both of these, which I didn't think we needed to. But what we're going to need to do really is we're going to have a function to reset aliens. We're going to say void reset aliens. And what we'll do is we're going to iterate through our array size, and say for int I equals 0, I is less than alien status array size I plus plus, and we're going to just set our alien status I equal to, and then when we call our constructor, so when we create our alien object, we will reset the aliens. And this is good because we're going to need this anyway, like if you were going to start like a new game or something. And let's see if that solves our first problem, where it was only drawing the top row. Okay. We might have some other logic issues here, I think. So that's, now we got 2 rows of aliens. And so now I fire. Oh, that worked. Pretty cool. Oh, didn't lose one there though. Wonder why. Interesting. Okay. So when we're getting the ones in the top row, it's not detecting the collision. But we're getting the ones in the bottom row, it is working. Okay, so another little bug there that we got to figure out. Okay, so why are we getting the bottom row but not the top row? Okay, so I've gone ahead and add some debugging information here, where oh, interesting. So the issue is this. So that's so what's happening is that, so basically I made it so that it detected when there was a collision. And so what's happening is that when we get rid of the alien in the first row, it's still detecting a collision there. And so we need to not check for a collision if the alien is visible. So we have to get, if the alien is visible already, or is not visible anymore, we don't want to detect a collision. So what we're going to do is if get alien status, get what was it? Get alien index, and then we'll pass in the y and the x. So if that's visible, if that comes back true, then we'll do all of these things, and then if not, we'll skip it. And so let's see if that solved it for us now. Oh, didn't like something there. Let's see. Okay. If get alien status was not declared. So that closes out that. Oh, we got a missing bracket somewhere. If. Oh, no, it's up here. Okay. Collision. Okay. So this matches with. Oh, yeah, it looks like we're missing one. True and false. So that goes with that one. Or do we have an extra one? So we check the collision. So we need another bracket for this one. Is what the problem is. Okay. I think we're good now. No, that's why there's an extra one here, is the problem. Okay, so now, there we go, now we're good. We had drawn one when I wrote it, and that was the issue. Okay, so now let's check it out. Yep, now we can get the second row. So the issue was that when we were checking our collision, we were registering a collision if we had already, that alien had already been eliminated, and that was the problem. And so now, our game is coming along pretty well. We're able to move around, we're able to fire the laser, we're able to eliminate some of these aliens, and we're getting pretty close to done here. So it would be nice if there's maybe like a little explosion. We also need to detect when the aliens get to the bottom, so like the game's over, stuff like that. So we're getting pretty close, but a fair amount left to do still.